All right, derivatives from graphs and tables. In calculus, we often examine graphs of functions to answer questions. So consider the function whose graph is given below. At how many values of x between a and b is f prime equal to 0? Yeah, so just what do you think? What were you looking for when you said 4? Will, I like that answer. How did you know it was 4? Wait, what did you say? What kind of slope? 0 slope. Be careful, because no slope is this, 0 slope is this. So we're looking for a slope of 0. So yeah, 1, 2, 3, 4. So there's 4 times where there's a horizontal tangent line, if you want to sound really fancy. But yeah, you're just looking for a slope of 0. At how many times is f prime, the derivative, non-existent? And what point is that? And why is that? There's a cusp there. Okay, that last one's kind of tricky. Maybe at how many times does the sign of f prime change? Oof, I don't know what happened to that Sharpie, or that marker. How many times does the sign of f prime change? So we could say slope changes signs. That would also mean f changes directions, like increasing, decreasing. So have you counted up how many times?
6.
Thank you, sir. Let's see. So decreasing to increasing. So there's 1, 2, 3, 4, 5. I think I count 5. Slope changes signs 5 times.
So you don't count the one that it starts?
You don't count the one that starts because it hasn't changed. Right? How many times has it changed? It starts negative, but it hasn't changed yet until it changes from negative to positive, positive to negative, and so on. All right, number 2. Consider the function whose graph is given over here. Which of the following is true? Oh, f prime at -1, f prime at 4, f prime at -3. So we got all these little slope pieces. So I guess we just need to find all these slopes. F at -1, that would be right there. That slope is, what's the slope of that line? Oh, you do need a packet. Right there. Nope, that's the worksheet, sorry. Definitely negative. Rise over run, that looks like -1/2. F prime at 4, 1, 2, 3, 4, will be on this line. That slope would be, let's see, we went down 6 and over 6. That's nice. So that slope is -1. So already A is out, right? Because -1/2 is not less than -1. But we'll need these values again, I think. Goodness, this is just annoying. F prime at 1. That looks like a slope of 1. F of 1 is 2. That's not a slope, that's the function value. And then f of 3, 1, 2, 3, that's also 2. So B is close, but no good because of the 2's there. f of 5, 2, 3, 4, 5. F of 5 is 0. F prime of 1, we already found, that's 1. And f prime of negative 4, 1, 2, 3, 4 is right here. So I need to find that slope. I can tell by looking at slopes more than 1, though. So I'm probably good to go ahead and answer C. Let's see, that rises 6 and runs 3, so that slopes 2. Again, nothing new, just using what we know in kind of different ways. If h of x equals 2x times f of x, find the derivative of h at negative 4. So what rule am I going to need for the derivative of h? If this is h. Product rule. So I'm going to do first times derivative of the second plus second times derivative of the first. And if we plug in negative 4 for all those places that have an x, 2 times negative 4, f prime of negative 4, I don't know what that is, I'll need to use the graph. F of negative 4, again, I'll need to go to the graph. Let's see, f prime of negative 4. Oh, we already found that, that's 2. So negative 8 times 2 is negative 16. F of negative 4, 1, 2, 3, 4, I think that is negative 2. So negative 16 and negative 4 make negative 20. Number 3 here. Now we've got a table. They've given me x, and they've given me a function value at f, a function value at g, and then the derivatives at f and at g. So let's see how we put all this stuff together. Suppose f and g are differentiable functions with the values shown above. If h of x equals f minus 3g, then h prime. There was one kind of like this on the test. The derivative of f is f prime. Derivative of g is g prime. And so now I'm just looking at the table. Goodness, gotta be super careful here. F prime at 5. Let's pick on people here. Why am I the only one talking? So f prime at 5. So it's just, I mean, you don't have to do anything except look in the right spot, right? Or what's f prime at 5? So this is what I'm trying to find. I want to find f prime. So I'm looking up here. So what's f prime equal to? 2. And Cody, how about g prime? Negative 0.5. And that is a safe stop. So we could leave that alone if we wanted to. Or we could say it's 2 plus 1.5 is 3.5. But we could have safe stopped. Alright, part B. If h of x is 2 times f times g, then Graham, what's the rule I'll need for part B? I need the product rule. So let's do the product rule first, and then we'll go to the table. So 2, and again, product rule, it's hard to mess up. As long as you get one derivative and one not derivative, you'll be okay. So f prime g plus 2 fg prime. So I can call in 4 people. We've got to pick the right values here. So Tristan, what's f prime? 2. Helen, what's... Oh, it's not there. Bump it up here. Avery, what's G? Yep. Elizabeth, what's F? 6. And Leah, G prime? Negative 0.5. And that would be a safe stop, so you could leave that as an answer. Let's see, negative 16 minus 12, half of 12 is 6. Oh, minus 6, so just negative 22. So again, today is nothing really new, just being careful, keeping up with things you already know. Looking at part C, good for people who are here. Hector, what rule am I going to need for part C?
It's that last one, topic 6, I forgot what it was. It was the one with the what's it called, the blow pops.
Yes, that's...
Chain rule.
Oh, no, I'm sorry, that's not the chain rule.
The chain rule, no, the quotient rule. That's
The quotient rule, because we're dividing. And I think to avoid hassles, I'm going to put the 2/3 out front and then do the quotient rule. Otherwise, I got to keep up with 2 and 3 and end up squaring 3. So just slide the 2/3 all the way out front, and then the quotient rule. Sayla, can you remind us what the quotient rule is?
Is it Gx and then F prime and then minus G prime minus F over G squared?
Yep, I left out all the x's just because it's easier to write without all the parentheses x's on there. But yes, gf prime minus fg prime over g squared. So again, not hard. Now you just got to carefully look at all the, like, go find the right spot. So g is negative 4, f prime is 2, g prime is negative 0.5. I don't know why we threw a fraction in there, just to mess with you. F is 6 all over g squared, so that would be 16. And just to emphasize the fact that we're okay with safe stops, I'm going to safe stop that and not even clean it up. If it's a free response, you are welcome to safe stop and be done. Thank you, sir. Emma, how about part D? What rule are we thinking there? Chain rule. Okay. So chain rule, outside in, blow pops. There was one that was nearly identical to this on the test. F prime of g of x, right, one layer at a time, there's our outside layer, times the derivative of the inside, so times g prime of x. Laura, I think that was the last one you were working on before you turned it in, and I don't think you got that one.
I think I didn't even end up solving that one. I just circled around.
Okay, so I want h prime at 5. I'm not going to be, like all the previous ones, I was kind of lazy about not writing parentheses 5 because just everything was at 5, so I wasn't really worried about it. But now with this composition thing going on, like g of x inside f prime, I think I'd better be real careful about where the 5 goes. Especially since they're telling me that f prime at negative 4 is 7. That, I'm guessing I'm going to need that at some point. Okay, so x is 5. So 5 is my input to all the x places. All right, well, work from the outside in. Claire, what's g of 5? Negative 4. Isabel, what's g prime at 5? This one, G prime at 5,
Oh, sorry. 0.5.
negative 0.5. So the last thing I need is F prime at negative 4, which I guess if you're not paying attention maybe seems weird because like, wait a minute, that's not on my table. Well, it's not on the table, but they told us what it was. So 7 times negative 0.5. That's a safe stop, but that's also an easy one. Negative 3.5. Questions? Don't want to fly through this. Was that it? My face was in the way. Let's see. Oh, this one looks a little harder because there's 2 rows to the table, but that shouldn't be too bad. We just have to be careful here. H is f of g of x. Okay, f of g of x. Maddie, what rule am I using when I see f of g of x? Definitely the chain rule. So f prime of g of x times g prime of x. Outside in, one layer at a time. And we'll plug in 6. So f prime of g of 6 times g prime of 6. Alright, well this one's a little harder because I got 2 rows to the table, so I got to slow it down a little bit with what I'm looking at. Laura, what's g of 6?
4.
G at 6 is 4. And Audrey, what's g prime at 6? E. Well, that's kind of weird, but oh well. And then I need f prime at 4. Evan, what's f prime at 4? Pi. Oh, so that's a fun answer. Pi times e. But I don't have to do anything with it, so I think we're good. Wait, is that right? Yeah, the keynotes are wrong. Huh. Evan, you're smarter than Miss Murray. Congratulations. Part B. What rule we use for B? What rule is that? Quotient. Why don't you try B and C? Try B and C. Look at the table. F of 6 is 4. F prime of 6 is negative square root 5. F prime at 4 is pi. So pi times negative root 5. That's a lovely answer. Alright, we did one like D. We can skip that. Yeah, let's talk about E. Explain why there must be at least one value of x at which f prime is equal to 0. Between 4 and 6. This sounds like intermediate value theorem. Right? So maybe we should find f prime at 4 and f prime at 6. F prime at 4. F prime at 6. Let's see. Again, got to look at the right column here. F prime at 4 is pi. F prime at 6 is negative root 5. So what do we think? Is 0 intermediate to pi and negative root 5? So this is IVT. 0 is between pi and negative root 5. Yes, sir?
It's never stated that
Okay, so I can't make a conclusion yet until I know that this is continuous. So you're right. I need to say something about f prime being continuous for this to be true, right? Otherwise, f prime's jumping around. And if all we have is the table, maybe it does jump around. Is there something in this problem statement that would suggest that f prime is continuous?
Oh, f and g are twice differentiable.
If f is twice differentiable, f is twice differentiable, that means it has a second derivative. So f double prime exists. And the only way for f double prime to exist would be if f prime is continuous. So that was the tricky part about this one, is getting to the fact that f prime is continuous. And how did we know that? Well, we knew it because f double prime exists. Second derivative can't exist unless the first derivative is continuous. So f prime is continuous. 0 is between these two. My statements are a little out of order if we're thinking back to the IVT order. 1, 2, and 3 is just the conclusion. Therefore, f prime equals 0 on 4 to 6. Because 0 is in between the two endpoints, and we know that f prime is continuous. Let's see. We don't really need to do all of these. That looks like a chain rule. That looks like a chain rule. That looks like a chain rule. So those were graphs. Oh, 8 looks crazy. Let's look at 8. The table above, so another table with all sorts of things up there. F prime, F double prime, G prime, G double prime. Gives the value of twice differentiable functions f and g and their derivatives at x equals 5. Wait a minute, something's not right here. This says x equals 5, the table says x equals 6. So I think that needs to be a 6 to make this work. Okay, h prime of 3 if h is f of 2x plus g of x squared minus 3. So how am I going to take the derivative of f? Braden, any thoughts on what the derivative of f of 2x is? Kind of putting you on the spot here. We haven't done one quite like this.
What?
The derivative of f of 2x. We'll worry about g later, like one step at a time here.
F prime 2x times 2.
Very nice. F prime of 2x times 2. Chain rule. All right, Braden took the hard one. So, Marie, you can kind of follow that example. What's the derivative of g of x squared minus 3? Very nice. Chain rule. And kind of a weird chain rule because we don't know what f and g are, but we do know what's on the inside. So it's like one symbolic derivative, f prime and g prime, and one like actual derivative, 2 and 2x. All right, h prime of 3 means let's plug in 3 for x. All those places. So that's f prime of 6 times 2 plus g prime of 9 minus 3 is 6 times 6. And then f prime of 6, that's on the table, but you just got to know where to look. So, Will, what's f prime at 6? negative 3. And Trevor, how about G prime at 6? 2. This would be a safe stop. The step before would not be a safe stop. You've got to evaluate. You can't leave F primes and G primes as part of your answer. So that would be a safe stop, but negative 6 plus 12 is 6. There's your multiple choice answer. Yeah, let's do B as well, because this is... So Daniel, what rule are we using for B? Quotient rule. I'm going to put the 1/2 out front, so I don't have to worry about that 2 every spot. And why is this quotient rule like harder than the previous quotient rules? Okay, there's 2 things, and you said them both. Like G is in the top, not the bottom, so that's kind of crazy. But the bottom's already F prime, so when I take its derivative, what's the derivative of F prime going to be? Double prime. Okay, so the quotient rule is normally GF prime. Or this is where starting from the bottom and working your way up is maybe an easier way to go. So bottom times derivative of the top. So F prime times the derivative of the top minus top times the derivative of the bottom. So G times F double prime all over the bottom squared. So quotient rule, but tricky quotient rule, because we had everything all mixed up. Now it's just a matter of looking at the table and finding the right pieces, which I think is simple enough. Let's start the worksheet. Let's do some off the worksheet together. That way we'll have time to knock some of this out.
No, I'm also
I've never even spoken.
All right, let's do a few of these together. Let's make use of our time here. Ugh, that first one, you just got to find all those. Wait a minute, I'm not going to be able to get exact values here because this is just a picture and it's curvy, so it's not like the slope in the. So I think I'm going to have to just be very careful. What do I know about F prime at 4? It's positive. That's all I know. And if I've got positive less than, I'm doubting that's the right answer. What's F prime at 3? That's one that I can know for sure. That's 0. So positive less than 0, that guy's out. My guess is I'm going to need this to go negative is less than 0 is less than positive. That's probably the only way this is going to work. F prime at 1 is 0, so that's probably not it. F prime at negative 2 is negative. F prime of 0 is positive. That one's out. F prime at 2 is negative. F prime at negative 1 is 0. I think I found it. And F prime at 0 is positive. So answer choice D. So try 1, 2, and 3. See if you can get through that first page. Are you okay with g prime of g of x times g prime of x?
Plus what? The second part? G prime times G of X.
G prime of g of x
Yeah, plus.
times, chain rule, g prime of x. Where this is the second g is that g. That's the inside g. This is the outside g. Yes, no?
I was doing product roll.
But that's not multiplying. That's a blow pop thing right there. G of x.
Yeah.
It's a blow pop thing. Keep going, or that's the source of the mistake.
Yeah.
Can I see the rest here?
Yeah.
Thank you.
Oh, he's from 1.